I press record, share the screen. Okay, I'm not going to lecture that long at all today. I'll just introduce the last section and then we'll go straight to the quiz. Okay, since you might want more time for the quiz. So we are here. I was actually completely done with 4.8. So that means I just have 4.9 left. And I'm going to try to finish it all by Wednesday. That should be plenty of time. So next Thursday, questions and answers, and Friday's a test. Right? Okay, so that's what's happening. So I've completed up to here. So I just have this to do. So what do I turn in for homework, you say? All of this. Again, there's a 70% rule. You have to turn in at least 70% of the homework. I end up doing, you know what, a huge percentage, sometimes even half the homework. Sometimes I almost end up doing all the homework. So the 70% rule should not be that difficult. So you turn that all in for next Friday's test, right? That would be November the 6th. Okay, we're ending the semester very quickly. So after this, there's just a small section here, test here, and then we're done. And not to mention, once November comes, which is starting Monday, holidays abound. We got a holiday for Veterans Day. Thanksgiving is here somewhere. And then before you know it, we're all finished. Okay. All right. So I'll introduce the last section, but not go that far. So 4.9, we have the law of cosines and the law of sines that you've probably had previously in your trig class. Okay, the law of cosines and the law of sines apply to any triangle. Okay, you don't necessarily have to have a right triangle, although it works for right triangles also. So the nice thing about law of sines and law of cosines, they will work for any triangle, whether you have a right triangle or not. Now, the SOHCAHTOA rules that we had before, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. That doesn't apply for general triangles. That only works for right triangles, right? But we can use the law of cosines or the law of sines for any triangle, right? So here's the law of cosines. I'll show you the law of sines in just a second. Now, one convention that you want to use, okay? As you can see, for a general triangle, they have A, B, C, little a, little b, little c. Okay? These are Greek letters, alpha, beta, and gamma, which in my opinion, you don't really need them. You can just use angle A, angle B, and angle C. Okay, but the first three letters of the Greek alphabet are alpha, beta, and gamma. Okay? Now, the convention is the big letter and the little letter always are opposite each other. So notice point A and side A are opposite. Point B and side B are opposite. Point C and side C are opposite. Okay, and as far as I'm concerned, you could have just survived by saying angle A, angle B, angle C. Okay, so that would work perfectly fine. But they decided to use alpha, beta, and gamma. Okay, so notice alpha is opposite A, beta is opposite B, gamma is opposite C. Alpha, beta, gamma, first three letters of the Greek alphabet. Okay, so you have this law. Put that on your next cheat sheet. Okay, A squared equals B squared plus C squared minus 2BC cosine of alpha. Okay, or there are two equivalent forms. Okay, it's up to you how much you want to put down. I mean, if you understand the principle here, let's say you have A squared, then you square the other two sides, and then it goes minus 2 times BC cosine of alpha, cosine of that angle. Okay, so in my opinion, if you have that, you don't really need these, okay, because it's the same principle. B squared equals, put the other two letters squared, A squared plus C squared, minus 2AC cosine of that angle, so cosine of beta. And similarly, C squared is equal to A squared plus B squared minus 2AB cosine gamma. So in my opinion, these three are really the same formula. Okay, do you want to put all three on? I don't think you need to, as long as you understand the principle of one of them. A squared is B squared plus C squared minus 2BC cosine of alpha. These are really the same thing. You're just switching the letters around, and they're equivalent. Okay, the book does go over a proof of it. I won't look at it. You can look at it if you want to. Okay, but it's provable. the way you do it is you draw a right angle like so, draw the perpendicular, and you can figure some stuff out based on that to get the law of cosines. Okay, one side note you might notice is, let's look at this one. C squared equals A squared plus B squared minus 2AB cosine of gamma. Okay, if gamma happens to be 90 degrees, okay, that means there's a right angle. Okay, cosine of 90 turns out to be 0. That means it wipes all of that out. And what are you left with? You're left with the Pythagorean theorem. Okay, so the Pythagorean theorem can be thought of as just a special case of the law of cosines. Okay, so the law of cosines works for any triangle, okay, which means if it works for any triangle, it also works for a right triangle, in which case gamma is 90 degrees. Cosine of 90 degrees is 0. So C squared equals A squared plus B squared. Okay, I'll hasten to add something else. For this section, for the homework problems, we will normally do the problems in degrees. So when you do these problems, they should be in degree mode, not radian mode. Okay, so we're going to find angles to be 42 degrees or 35 degrees, not pi over 7 or anything like that. Okay, so law of cosines, here they are. They're all the same. So I can just present one. If you get the idea of one, you got the others. Okay? And the naming convention, right? A opposite A, big A, little a, big B is opposite little b, big C is opposite little c, and alpha, beta, gamma are the angles. Technically, A, B, and C are the points, but to me, you could survive by saying point A, that's also angle A, right? And that's also angle B and angle C. So anyway, but the book uses alpha, beta, and gamma. So alpha, first letter of the Greek alphabet, opposite A, beta, second letter, and gamma, see, I know gamma to us doesn't start with a C, it's G for us, but anyway. But you can't really confuse it because A, alpha, B, beta, so there's not any choice for the last one. For gamma, it's opposite C. Okay. Then we have the law of sines. Okay, this looks like a lot easier formula. Same picture. Okay, A opposite A, B opposite B, C opposite C. And again, alpha opposite A, beta opposite B, gamma opposite C. So there's always that naming convention. Okay, then sine of alpha over A equals sine of beta over B equals sine of gamma over C. And again, it's provable. You could draw a triangle here and do some relationships. You can prove that these are equal. I won't go over that. You can look at it if you want to, but it's definitely provable. Okay. In some books, they just say sine of A over A, sine of B over B, sine of C over C, which makes sense. Right? Then you have A, B, B, C, C. Okay, so this is the law of sines. I will also add, sometimes you see these where all three of them are flipped. It's the same formula, really. Okay, so I've seen forms of the law of sines where flip, flip, flip. It would be A on top and sine alpha on the bottom equals B on top, sine B on the bottom equals C on top, sine gamma on the bottom. It's the same thing. They're equivalent. Okay, and for this law of sines, quite often you would do the cross multiply route. Remember cross multiply? Okay, so if you only look at, let's say, these two, you can go that times that equals that times that. In other words, A times sine of beta equals B times sine of alpha. Okay. Sometimes you have to use, let's say, the first and third ones. So you cover up the middle one, and you can go sine of alpha times C equals A times sine of gamma, right? So that will happen quite a bit. So there's a lot of cross multiplication going on. Okay, so this is the law of sines. You may put it on your next cheat sheet again. Again, if we were meeting face to face, I'd make you memorize it. But here we are. Okay, so law of cosines, page 261. And page 264, law of sines. Okay, now, at first glance, you might say, well, this is way easier. Why don't I always do law of sines? I don't ever want to do law of cosines. Okay, so why would I ever want to do law of cosines? Because sometimes you're forced into it because you don't have enough information from the law of sines. Okay, in particular, okay, now, normally what we're doing is what's called solving the triangle. So what is solving the triangle? That means you give every side and every angle. Okay, So you have 1, 2, 3 angles and 1, 2, 3 sides. Okay, now, typically in the homework, they will give you 3 pieces of information, which might be 3 sides or 2 angles and a side or 2 sides and an angle, something like that. Okay, then from those 3 pieces of information, can you get the rest? Okay, so let me just show you what the homework is like. I'm not doing any homework, but 4.9, page 271. And yeah, I'll show this to you for those of you who don't have the book and don't plan on getting it. 3 pieces of information, right? Like alpha, B, and C, or alpha, beta, and C, right? 3 pieces of information, alpha, B, C, A, B, C, or whatever, right? Looking at some more. Well, it's a little bit harder to see this because you've got word problems. Okay, but they give you 3 pieces of information. Okay. And by the way, one information that you always want to use is the sum of the angles in a triangle, right? The sum of the angles of any triangle is always 180 degrees, right? So that means if they give me 2 angles, yeah, look at number 6. You have 2 angles, right? You automatically can figure out the third because you know they all have to add up to 180 degrees, right? So in my mind, it's very easy once they give you 2 angles, because once you have 2 angles like alpha and beta, right? You know all 3 have to add up to 180, so you would just subtract the sum from 180 and get the third angle, right? Okay. But you see other combinations here. Now you say, why don't I always do the law of sines? It turns out you can't do it. Okay. In the 3 pieces of information, if they give you exactly one of each letter, you can't do the law of sines. Okay, so suppose they give me 3 sides. Like this is 7, this is 10, and this is 11 or something like that. There's no way that you can solve. Okay, or suppose they give you alpha, they give you beta, and they give you C. Okay, that's not enough information right away. Or they give me A and B and gamma. There's no way to cross multiply to figure it out. Then you're stuck. You do have to do the law of cosines. So I can make a hard and fast rule, but I think it's probably easier to just say, try the law of sines first, because it's easier, right? And then if we get stuck, do the law of cosines. Okay. We could make hard and fast rules if we wanted to, okay? But you can just say, well, law of sines looks nicer, right? So I will do a law of sines until I find I'm stuck, I can't get anywhere. Then I'll switch over to the law of cosines. All right, and then something else I needed to show you. We have some problems involving Heron's formula, page 270. Okay, if you're given 3 sides of a triangle, there's something called Heron's formula. Okay, I will show you my version. What they have is actually correct. I don't like the way they present it. Okay, so I'll give you the Melvin Hum version later. Okay, but if you have 3 sides of a triangle, you can actually find the area. Okay. Now you're probably used to 1/2 base times height for area. Okay. Well, as you can see, they do a derivation of that. If they give you 3 sides, you can do some trig and some geometry to figure out what the height is, and it ends up being this messy formula. Okay, I don't advise you to use this formula. I'll give you my version eventually. Okay, so I'll give you my summary, and then I won't go much longer. Okay, so when we start on Monday, we can actually work out some problems. So law of sines, law of cosines, and area of a triangle. Okay, so this is just like before. A, B, C, little a, little b, little c, alpha, beta, gamma. So law of sines, sine of alpha over A equals sine of beta over B equals sine of gamma over C. Okay, I should say there's actually some trouble sometimes with the law of sines. Okay, it has to do with the fact that if you have an angle that's bigger than 90 degrees, okay, so if I say sine of an angle equals some number, you could have 2 possibilities. Like the sine of alpha is equal to 1/2. Okay, you've got 2 answers possible. You have a first quadrant and a second quadrant angle. That might lead to some ambiguity, and we'll talk about that next week. Okay. Law of cosines, there's no ambiguity, which is nice. So here's law of cosines. A squared equals B squared plus C squared minus 2BC cosine of alpha. Okay, put it on your cheat sheet if you wish. And there are the 2 equivalent versions. Okay, now, you can write it or not if you understand the principle again, that you have 1 side squared equals the other 2 sides squared minus 2 times that times the cosine of that angle. Okay, so these are all the same thing, like we said. Okay, b squared, a squared, c squared, 2ac cosine of that beta. Likewise, c squared, a squared plus b squared minus 2ab cosine gamma. Okay, so they're all equivalent. Okay, so what we're going to do is solve for a triangle, solving the triangle. Okay, so generally they give you 3 pieces of information. See, an angle and 2 sides. Find everything else. Okay, or they give me 2 angles and a side. Okay, and again, this is pretty easy because if they give me 2 angles, the first thing you should always do is find the third angle, right? Because you know all 3 angles have to add up to 180. Okay, then other variations, they give me 3 sides. Okay, so I'll have to show you that eventually. Yeah, so let's say this one, they give me 3 sides. You can still do it. You can't do the law of sines there because you have exactly 1 of each letter. You do the law of cosines. Okay, then I'm going to give you my version of finding the area given 3 sides. So this is the one I want you to use. In fact, most books have this. Okay. So if you have 3 sides, A, B, and C, first we have to define something called the semi-perimeter. Semi-perimeter is half the perimeter, A plus B plus C over 2. Okay, so given 3 sides, let's say this is, I want to just pick this, 8, 9, and 13, right? Okay, so from that information, you can actually find the area. First, you find something called the semi-perimeter. Add the 3 sides up and divide by 2. And then you go, the area is square root of S, and then S minus each of the sides, S minus A, S minus B, S minus C. Okay, you can put this on your next cheat sheet. Okay, now this is equivalent. It's equivalent to what the book gives you, but I like this one better, and most books have it this way. Okay, so let's say you have 8, 9, and 13. So first I find the semi-perimeter. All right, add them up and divide by 2. So in this particular case, it'd be 13 plus 9 is 22, 30. 30 divided by 2 is 15. So you put a 15 here, 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 and here. And that would be 15 minus 8, 15 minus 9, 15 minus 13. Okay, I'll show you all this next week. Okay. All right, so that's exactly what's going to happen next week. I will now stop and give you the quiz. Okay, so get your cell phones out, ready for the quiz. And then I'll put you in your breakout rooms. And again, I might move you to a different breakout room if your breakout room gets to be too few people, like only 1 or 2 and whatnot. Okay, so as usual, do Monday at 9:10. And you actually have 1 more hour this coming weekend, right? Because we have to turn our clocks backward 1 hour. So this weekend is actually 1 more hour than usual. Okay, so you're given sine of theta is 4/5. Theta is between 0 and pi over 2. That's nice. So find each of these. Sine of 2 theta, cosine of 2 theta, sine of theta over 2, cosine theta over 2. So there are formulas for each of these. Use the formulas the right way. Okay. Now, the formula that I gave you is probably in terms of sine squared. Right? There's a formula for sine squared, which means after that you just take the square root. Okay, so I'll leave this up for another few seconds, but I'll put it away. It's still being recorded, so worst comes to worst, you can look on the video later to catch it. Okay, sine of theta is 4/5, which means first you got to figure out cosine of theta, right? Theta is between 0 and pi over 2, nice. So sine of 2 theta, cosine 2 theta, sine of theta over 2, cosine theta over 2. Okay, so I'll make the assumption everybody has it now, and I'll set up your breakout rooms. So go ahead and get started. Okay, you should have an invitation to go to your breakout rooms, so please join your breakout rooms right now. So Jason and Risa, you could join your breakout room, please.